Good day, ladies and gentlemen. Welcome to this presentation on Project Management System Approach, Part 1. In this presentation, we will look at the following. The objective of this presentation. Why a system approach? Characteristics of a system. Modeling of systems. Project requirement or scope. Requirement management, the system engineering process and specifications, and testing of components and subsystems. Now, the objective of this presentation, to motivate the necessity of incorporating a system approach in project management by giving a very simplified or abridged background on system thinking. In other words, the content will be limited just to lay a foundation for system thinking. Why a system approach? One cannot afford to overlook anything in project management, and systems are everywhere. The harsh reality is that anything that is overlooked at the planning stage will have to be addressed later with dire consequences, because then you have not included it in the costing, time scheduling, and its effect on other items in the project. Characteristics of a system. This subject can be vast and complicated. A key characteristic of a system is that it consists of levels and has consistency over system levels and among components. Example: in a hostel, the number of ablution facilities, the size of the dining room, the number of stories, the size of the kitchen, size of the laundry, electricity supply, etc., must be in line with the number of inhabitants of the hostel. Over here, we have the 3 dimensions of a project. Along this horizontal axis here, we have the timeline, in this case in months. This vertical axis over here represents the system levels, starting from system level number 1, which is of course material. Now examples of this would be steel, plastic, copper, glass, whatever. Then on system level number 2, we have components such as an oil pump or oil filter or a wheel and so forth. Then on system level number 3, we have subsystems such as the electrical system, the aircon system, the cooling system, and so forth. Then on level 4, we have the integrated system. In this case, it would be the complete car that can drive. Now on level 5, we have logistics. Now the logistics includes documentation such as workshop manuals, tools and special tools, and facilities, and so on. It's interesting to know that a product cannot exist for long without the logistic support from level 5. Now on level 6, we actually have the user system. These are the thousands of people that buy the vehicle and use it. They are the user system. Now there is also a third axis, and this axis runs into the whiteboard. In other words, it's a 3-dimensional presentation, this, and it represents the interface with other projects, in this case project A, B, and C, and so forth, which might have interfaces with your project. So, wherever you are, whatever you talk of, it's good to be conscious of where you are on each one of the three axes. Over here, like with the previous slide, the horizontal axis represents a timeline in months once again. The vertical axis, the system levels once again. Now we've tried to indicate some interfaces here. For instance, on level 3, you might find that there has been an engine change. So part of the fleet will have the old engine from the beginning to month 10. And the other part of the fleet will have the new engine from month 6 onwards, like that. Past month 10, of course. Now what you see is between month 6 and month 10, you have a duplication of configuration of engines. Now this can be very risky and challenging. And at the same time, you actually notice that on level 5, where the logistic support is like log documentation and even tools, special tools, personnel and all that sort of thing, training, you also have a duplication of configuration. But that should not surprise you, because the configuration here on level 3 dictates what support is required on level 5. So, if one has a duplication of configuration here, one will have it there too. Now let's talk a little bit about interoperability. Firstly, let's say what it is. Interoperability is the working together between systems. So, example of that would be a fighter jet that has to refuel in the air from a cargo plane. And usually the telecommunication plays a paramount role. Now, in this, and obviously there are other interfaces, very serious interfaces too, like physical and functional interfaces, to make sure that the transfer of the fuel is successful. But communication is very important. Let's also consider a situation where the Air Force works together with ground forces in a combat situation. Once again there, communication is of prime importance to make sure that they can work together. So what we actually see here is between the time 0 and month 12, there was no interoperability. In this case, it is something that has been brought in. System boundaries. System levels could reach very high levels, such as with international military systems, such as NATO. It is advisable to define the system scope to where your analysis and your responsibility will be limited. System behavior. Examples would be performance as per specification, stability, coverage, timeliness, quality, etc. Modeling of systems. It is said that if you can't model something, you cannot understand it either. And if you understand something only in part, then you can only model it partially. It is therefore important to model a system, to understand it. It must be understood that a model is not the complete reality, but only a projected view thereof. Example, the stresses of a structure can be modeled, but there is more to the structure than just stresses. Different types of models. There are physical models, which could be full scale or modified scale. Schematic block diagrams, just to indicate the sequence of a process. Computer-assisted drafting, or CAD. These are drawings on a computer to assist with the packaging and layout of components. Analytical modeling. This is one of the most important and comprehensive models. Based on calculations and used to predict the behavior of a system. It could include calculations to confirm the strength, dynamic behavior, example transient and steady state response to show how fast the system reacts to inputs, performance, that is like capability as measured against a specification, such as speed or acceleration, stability, example, any oscillatory behavior such as encountered with vehicle handling, and much more. Project requirement or scope. It is said that projects fail at the beginning and not the end. By simply throwing money at a problem, one might as well throw it down the drain. Rather list the desired outputs of a project and couple payment to this by means of contract management, based on strict acceptance criteria and conditions. Always start a project by perusing the requirement critically. The client is usually very touchy about any criticism of his requirement, and the best of human relations are required here. If you cannot convince him, be polite and make sure your communication is in writing. What has not been written has not been said. What has not been written has not been said. Must the requirement be in functional or specific terms? Functional terms leaves a far wider scope for a better solution, opposed to limiting specific terms. Requirements must be complete, or much conflict will arise later as to what would be the best for the unspecified fields, and who should carry the cost thereof. The unlisted requirements will now also require additional time to include. It is also highly advisable to include a value system with requirements, so that choices can easily be made among alternative possible solutions based on functional characteristics. The requirement must be consistent and realistic. But how would one know if it is consistent and realistic? The answer lies in modeling the solution. Example, if many requirements for a vehicle are specified, but it is also required to weigh less than a certain amount, the modeling will show whether it is possible to meet this requirement of mass. The requirement must be verifiable. It has been said that if you cannot measure something, don't specify it. This could become a challenge for an aircon in an earth-moving vehicle, which is specified to work at 45 degrees centigrade. But when it has to be qualified, this temperature does not occur. Yet, the fixed delivery date beckons. Who's to blame now? A solution might be to make use of analytical extrapolation of the performance parameter, but this should have been provided for in the initial specification. The requirements must be traceable from the user requirements throughout the hierarchy of specifications to the lower system levels and must be verified as such at each baseline design review. This is, of course, to prevent scope creep, also as a result of personal preferences. The requirement must be concise. Avoid statements such as the system should do this or that, or preference must be given to. Requirements management. Reference has already been made to the review and traceability of requirements. But another dynamic that could rear its head is legitimate changes required along the project timeline. This is sometimes triggered by a shortage of a production component or a change request from the client or unattainable performance parameter. This change must be implemented with the greatest of care and is dealt with in the next presentation under the heading Configuration Management. The system engineering process and specifications. The system requirement is cascaded down from the higher system level to component level, each requirement with its own test description. This is the birth of the specification on all levels and for interfaces. Checklist for specifications. This list and its application gets quite big. But to illustrate the principle, a few examples are given below. A high-level summary of requirements would be quantity, quality, coverage, timeliness, and cost. Some lower-level parameters could be ergonomics, system safety, system reliability, standardization, system application and supportability, system behavior, electromagnetic interference, EMI, biological growth, interfacing with other systems, own subsystems, higher system levels such as users, heat transfer. The list goes on to well over 70 items, and most of these items represents a study field of its own. A program manager who has not had some exposure to these fields could find himself or herself out of their depth and unable to make the correct decisions. One can make use of specialists, but one must at least be conversant in these fields to, among other things, be able to contract the specialist suitably. Interface specifications. There are physical and functional interfaces. Example, physical addresses dimensions, mass, and material properties. Functional interfaces are based on behavior parameters. Example, power delivery, heat generation, reliability, system behavior, digital interfacing, etc. The same checklist used for specification must be used for the interface specifications too. Testing of components and subsystems. Qualification. This is an in-depth process done with big statistic sample size to ensure reliability and belongs more to the development stage of a project if reliability is included. A separate rundown on reliability will be offered in a future presentation. Complex electronic systems are often qualified by means of computer programs to ensure conformance. Verification. This is just to confirm performance. Example, electric motor at the end of a production line is coupled to a current supply to confirm rotation. Analytical qualification. Here a case is based on calculations as evidence that the system should work. Test procedure and results must dovetail with the specifications, which are of course cascaded down from the user requirement. If a required result is not attained, then serious deliberation is required to decide what is acceptable or not, and how it must be handled. This will also be addressed in the next part on configuration management. I hope you have found this presentation useful and not too abstract. If so, please remember to click on the like button and consider prescribing to my channel. Thank you.